Two 10-kilogram boxes are connected by a massless string that pass over a massless friction pulley as shown above. The boxes remain at rest with one on the right hanging vertically, the one on the left 2 meters from the bottom of an inclined plane that makes an angle of 60 degrees with the horizontal. Coefficient of kinetic friction and static friction between the left-hand box and the plane are 0.15 and 0.13 respectively. You may use G equals 10, sine of 60 equals 0.87, and cosine of 60 equals 0.5. Part A, we want to determine the tension in the string, so let's go ahead and do that. First thing I'm going to do is pick a direction. So let's make up the ramp as positive and down the ramp for the other block is positive. We're going to call these blocks block 1 and block 2. So we'll start with the free body diagram for block 1. So forces acting on block 1, we have mg straight down, and we'll have tension in the other direction. And then we'll apply Newton's second law. So F net equals ma. A is 0 because they tell us they are at rest. So we have F net equals 0. F net is mg minus tension, because mg is in the positive direction, tension is in the negative direction. Okay, and then solving for tension, we have T equals mg, which equals 10 kilogram times 10 meter per second squared. So tension equals 100 newtons. Part B, we want to draw and label the forces acting on the box that is on the plane, so box 2. Forces acting on that box, we have mg straight down. We have normal that is perpendicular to the surface. We will have a tension force in the direction of the given string, and then probably some friction going down the ramp. Part C, we want to determine what that frictional force is, okay? And they tell us at the beginning of the problem that it is static friction. Well, they tell us that the box is at rest, so we can assume static friction, which makes the problem a little bit easier. So we will believe them, and we will assume that this is static friction. Okay, so anytime we have a problem like this, I always recommend to draw a pseudo free body diagram. Okay, we always change the axis so that the y direction is perpendicular to the ramp. So this will be our y coordinate system, and then, or our y-axis rather, and then our x-axis is along the plane. So that'll be the positive x, and that'll be the positive y direction. So tension doesn't change, keep it in the x direction. Normal doesn't change, and friction doesn't change. mg, there's going to be a y component, we'll call it mgy, and then an x component going this direction, call that mgx. And since we had to rotate our axis so that the x-axis lines up with the plane, with the slope of the ramp, that means that we turned it an angle of 60 degrees. So this angle right here with the old vertical and the new vertical, that angle is 60 degrees. If we take the sine of that angle, that'll give us that mgx component, and the cosine of that angle will give us the mgy component. Okay, so mgx equals mg sine of 60, which is equal to 10 kilogram times 10 meter per second squared times the sine of 60 is 0.87. So that means that mgx is going to be 87 newtons. Mgy, that'll be mg cosine of 60. Cosine of 60 is 0.5, so we'll have 0.5 times 10 times 10, so mgy will be 50 newtons. Okay, so for part C, we are going to do Newton's, we are going to use Newton's second law in the x direction for block 2. So we'll have F net in the x direction equals max, which is 0. It's at rest, they tell us. So F net x will be tension minus friction. They say static. They say it's not moving. Minus mg in the x direction. That equals 0. Solving for friction, we have static friction equals T minus mgx. Tension we said was 100 newtons, or is 100 newtons, and mgx is 87 newtons. So static friction is 13 newtons.